In 12.4, we're going to consider disjoint or overlapping events when we're finding probabilities. So we're talking about compound events here. And so if you look at this slide, when we refer to union of A and B, we're talking about all the possible outcomes of A or B, okay, or A and B together. So basically, it's just all of it, every single thing in the set, all the results of A, all the results of B, and anywhere also where they overlap. Those values are all in the union of A and B. In the second picture, we're talking about the intersection of A and B, and that's where we focus on the overlap. We're only interested in the intersection in where the solutions overlap from each other. In other words, what parts are in set A that are also parts of set B. And then in the third picture, we talk about disjoint events where you notice that there are no overlaps. Basically, everything that relates to A is just in A, and everything that relates to B is just in B. So again, understand union is all outcomes of either of the two events. Intersection is only the outcomes that are shared. Overlapping events are events that occur in common to both events. And then disjoint, or also known as mutually exclusive, are events that have no outcomes in common. So what we learn here is how to calculate the probability of compound events. If A and B are any two events, the probability of A or B occurring is going to be the probability of A plus the probability of B minus the probability of A and B. This part here represents the overlapped amount. Because, of course, if I go back to the last slide, if I take all the values in A and all the values in B, I'm going to be double counting the overlapped amount. So I have to kind of subtract that out. Now, if they happen to be disjoint events, then it's easy. Then the probability of A or B occurring is just the probability of A plus the probability of B. In other words, notice, when it's disjoint, you don't have to subtract the overlap. So let's start working some out and see how this relates. So we come over here to a six-sided die and we roll it, and we find, it says find each probability. So we're dealing with a dice. It says find the probability that the number rolled is less than 3 or greater than 5. So for A, we're looking for the probability that it's less than 3. And for event B, we're looking for the probability that it's greater than 5. So again, remember that we've got 1, 2, 3, 4, 5, and 6 on a die. So if I was to draw these, A and B, which of course I wouldn't expect you to draw all these out, but less than 3 is going to be option 1 or 2. That's the only numbers that are going to be less than 3. Greater than 5 is going to be 6. And notice that there's no overlap. So this is actually a disjoint event. This is actually just 1 and 2 and 6, and they don't have anything in common. So if it's a disjoint event, then I know that the probability of A or B is just going to be the probability of A plus the probability of B. So the probability of A less than 3 is 2 out of 6, or 1/3, right? The probability of B is going to be just 1 over 6, right? So actually, I'm not even going to simplify it to 1/3. I'm going to leave it as 2/6. So probability of A is 2/6. Probability of B is 1/6, and together it's 3/6 or a half. So the probability that you're going to get A less than 3 or greater than 5 is going to be a half, or 0.5, or 50%. Okay. The second one, B, says what is the probability of rolling a number greater than 4? So event A is the probability of greater than 4, and event B is an even number. So now we got to think about that, and we're like, okay, well, I got 1, 2, 3, 4, 5, and 6. Greater than 4 is 5 and 6. Even number is 2, 4, or 6. So notice again, if I was to draw these out, I would have an overlap here, right? The probability of rolling greater than a 4 is 5 and 6. And in B, the probability of an even number is 2, 4, and 6. So notice that there's one overlap here, right? So this is going to have to be treated with the formula, right? Probability of A or B is going to equal the probability of A plus the probability of B minus the probability of A and B. Okay, so now when I go to do the math, again, the probability of A is the probability of getting greater than a 4, which we notice is 2 out of 6. The probability of B getting an even number is 3 out of 6. And so now I have to find the probability of finding a number that's greater than 4 and even. Well, there's one number that's greater than 4 and even, so it's 1 out of 6. And so when I do the math here, I'm going to find that 2 6 plus 3 6 is 5 6 minus 1 6 is 4 6 or 2/3. So the probability is going to be 0.67 or 67%, or you could even do 0.667 or 66.7%. But that's the probability of A or B in this situation. So I had to find A and B and subtract the overlap. So here again is a standard deck of cards. Let me just kind of show you again how these standard decks are made of. Again, you have 4 styles. You've got clubs, spades, hearts, and diamonds. And you go from the ace, 2, 3, 4, all the way to 10. And then you have what we call your face cards, your jack, queen, and king of each suit. Okay, so there's a total of 13 cards per suit, which gives you 52 total cards. And then again, you've got your face cards. So there's 3 face cards for every suit. So if we come over here and we start asking questions, I'm going to refer back to that picture on the other slide. It says, a card is randomly selected from a standard deck of 52. Find the probability of the given event. So again, we've got to notice that we have 2 events here. Probability A, the first one, okay, is going to be of selecting a 5, okay? And the second event, probability B, is going to be to get a face card, okay? So first of all, we need to figure out if there's going to be any overlap. Is there any overlap between 5s and face cards? And you're going to see that there's not. So the probability of A or B, in this case, because there's no overlap, is just going to be the probability of A plus the probability of B. So the probability of getting a 5, well, there's 4 5s out of 52 cards. And the probability of a face card, there's 12 face cards out of 52 cards. So the probability of either or is going to be 16 over 52. And again, you can now simplify. I think I can divide, let's say I can simplify it by 4. Or, you know, if I want a simplest fraction, it's going to be 4 out of 13. Or 0.308 as a decimal, or 30.8%. Either one of these answers is acceptable. Simplified fraction, decimal to 3 places, or a percentage to the 10th place. Okay? And again, this was a disjoint event, so it was a little bit easier. Okay? Now, the second one says the probability of a face card. So probability A is the probability of a face card. And the second event, probability B, is probability of a diamond. And so again, we have to ask ourselves, is there an overlap? Can you have a face card and a diamond? And the truth is that you can. So this is a compound event. So this one is going to have a little bit different formula. This one's going to be probability of A or B is going to equal probability of A plus probability of B minus the probability of A and B. Okay? A and B. So let's start. What's the probability of A? Well, the probability of getting a face card is 12 out of 52. The probability of getting a diamond is 13 out of 52. Remember, there's 13 of every suit. And then the probability of getting a face card and a diamond, well, there's 3 face cards that are diamonds. So it's going to be 3 out of 52. So now this is 25 out of 52 when I add it. And then the 3 over 52 is going to leave me with 22 over 52, which simplifies to 11 over 26. That would be a valid fraction. As a decimal, it's 0.423, and as a percent, it's 42.3%. And so that's the probability of getting event A or B to occur, being that it's a compound overlapping event. Okay, so I'm going to erase this, and well, actually I can just scroll down here. Okay, so for C, we've got probability A is the probability of getting an ace, and probability B is the probability of getting a 9. And so again, I have to ask myself, is getting an ace or a 9 an overlapping event? And it's not. This is a disjoint event. So this one's kind of easy. This is, again, remember, the probability of A or B is the probability of A plus the probability of B. In this case, the probability of getting an ace is 4 out of 52. The probability of getting a 9 is 4 out of 52. So together, it's 8 out of 52. Or I could divide by 4 and I get 2 out of 13. That's the simplified fraction. The decimal is 0.154 or 15.4%. And the last one is selecting a 10 or a diamond. And this is going to have an overlap. And so this, again, probability A is probability of getting a 10. Probability of B is the probability of a diamond. And so the formula that I would use is probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. So again, probability of getting a 10, there's 4 10s out of 52 cards. The probability of getting a diamond, there's 13 diamonds out of 52 cards. Now, what's the probability of getting a 10 and a diamond, right? Well, there's 1 10 that's a diamond, so 1 out of 52. There's one that meets both those criteria. And so again, now we go through and we're like, okay, this is 17 out of 52 minus 1 out of 52. So it's going to equal 16 out of 52. If I divide by 4, I get 4 over 13, which I did earlier on something else. And it equals 0.308 or 30.8%. And so that's kind of how we solve these. And then the last one is a little bit more confusing. Basically, there's a total of 100 students surveyed. They tell you that 92 own either a car or a computer, 65 own cars, 82 own computers. What is the probability that a randomly selected student owns a car and a computer? So probability of A, let's make it a car. Okay, probability of having a car. Let's make B the probability of having a computer. And there is some kind of an overlap there, right? Because they're saying that some own either, but you know there's going to be people that have both. So this is going to be an overlapping scenario. So it's going to be compound. So remember that the probability of A or B is going to equal the probability of A plus the probability of B minus the probability of A and B. So let's just start filling it in. Notice it says here, 92 own either a car or a computer. So 92 out of 100 represents the people who own either a car or a computer. And then I keep going. The probability of a car, well, 65 out of 100 own cars. The probability of a computer, well, 82 out of 100 own computers. And so now it says, what is the probability that a randomly selected person has a car and a computer? So what we're looking for is this probability here that's missing. So minus probability of A and B. That's our missing thing. That's our variable. So if you look at it, right, I could add the probability of A and B to both sides. Think of it just in algebra. Probability of A and B, right, plus 92 over 100 is going to equal 65 over 100 plus 82 over 100. So kind of like that, right? So I just moved it over to the left side and they canceled. So now what if I do minus 92 over 100 from both sides? You're going to see that we can solve for the actual probability of A and B. It's going to equal 65 plus 82 plus 92. So 65 plus 82 minus 92 all over 100. That's going to be my final answer. So the probability of A and B is going to be 55 over 100, or 0.55, or 55%. So we were actually able to solve for the missing proportion just by doing algebra. We had this one here, right? We had this one here, and we had this one here. Since we didn't have this, we just solved for it. So that one's a little bit tricky, but I think you guys can do it.